This is Mona Rajans, and on behalf of Team AVRGo, I'd like to present the work we did on our research project titled Affordances of Augmented Reality for Procedural Learning in Manufacturing Environments. There have been numerous studies in the past that have concluded that enhanced visual representation for procedural learning provides some sort of benefit compared to more traditional learning mediums. However, attempting to develop AR content for every step of the training process is both costly and labor-intensive. Additionally, it is also highly unlikely that every procedural task will actually benefit from AR. Therefore, we wanted to identify any subcategories within the procedural learning domain that might benefit more from AR than others. We developed a cross-sectional study to evaluate the effectiveness of using different instructional representations to facilitate the learning of tasks that fall under the procedural learning domain, especially for manufacturing. Procedural learning tasks were broken down into three subcategories that are relevant to a wide range of manufacturing process, namely wiring, orientation critical, and pattern critical operations. The three mediums that we evaluate are written instructions with images, 2D animation, and AR animations. Participants were selected from a pool of skilled workers at an aerospace manufacturing facility. They were placed into three different groups, and after completing the experiments, they were given a survey. An administrator observed the participants as they completed each of the learning tasks and took notes about the mistakes or error that they made, while also noting the time each task took and recorded general notes throughout the process. The three different kinds of procedural learning tasks identified for this study were chosen because of the unique challenges and intricacies they posed during the learning process. These are orientation critical tasks, pattern critical tasks, and wiring critical tasks. These are also extremely important for almost all of the assembly operations performed in a manufacturing environment. Some examples of each of these tasks have been provided in the slide. We used three different types of mediums: written instructions with images, like you could see in the first image on the bottom side, 2D animation videos, and AR videos. The written training material was created using real photographs of assembly steps for each task. Cryoparametric was used to create 3D CAD representations. 2D animations of the tasks were created using 3D Max. And Vega, a proprietary AR work instruction platform, was used to transfer the animations into an AR application. This is one of the sample applications for an AR video. Traditionally, typically the user could go back and forth and verify any of the steps that they want to. We had conducted 2 trial sessions in order to identify areas for improvement in experimental setup and procedure. We identified that the written material had a few mistakes in the written instructions section. We had requested feedback from both the participants on experimental procedures. Both participants requested a better introduction to the modular board, parts, and general procedures. The trials also provided the administrator an opportunity to practice their system for keeping track of time and notes during the tasks. The biggest takeaway, however, from these sessions was the amount of time required to complete the tasks, and we ended up cutting down on a few tasks to bring the overall time taken to complete the experiment down to 30 minutes. While the participants conducted the survey, we noted the specific mistakes they made and categorized each of these mistakes. You could see the categorization of these mistakes on the right-hand side table. So for example, if a particular mistake was placing a bolt out of order, it was categorized as mistake number 2. On the left-hand side, we have plotted the total number of mistakes made per medium for each particular mistake. So as evident, mistake number 2 was the highest number of mistake for 2D animations group. Here we've plotted the total number of mistakes made by the entire group per medium. 2D animations had the highest number of mistakes, whereas AR had the least number of mistakes. We also plotted the total number of mistakes by procedural learning subcategory on the right-hand side. We had also noted the average time taken by participants to complete each task using different mediums. We noticed that AR proved to be the fastest for a few of these tasks. For example, pattern task 5, wiring task 2, and wiring task 3 were some of the particular tasks where AR proved to be fastest than any other medium. At the end of the experiment, we presented the participants a list of questions. Their responses were collected and analyzed for observable trends. Most of these survey questions were of the type where users had to rate their feedback on an ascending scale from 1 to 5. We had listed a mean of their responses on this table. This helped us understand from a participant's point of view their perceived understanding, their perceived speed, interest, what they felt about the particular technology that they used, and we have deduced certain conclusions from here. Overall, we'd like to say that while there are some trends that indicate enhanced learning mediums, such as AR, can slightly benefit specific subcategories under the overall umbrella of procedural learning, but we feel that, as we saw, AR completely eliminated or significantly reduced the occurrence of certain types of mistakes compared to other learning mediums. We feel that there is still a lot of work pending in this direction so that we could come to some significant conclusions. As you could see, we also did ANOVA analysis, a one-way ANOVA analysis on the total number of mistakes and time taken by the participants. We did not get our p-value to be lesser than 0.05, which is the industry standard. But in certain cases, we got it to be a closer number. For example, you could see that for pattern, the p-value is 0.0991. We believe that if we could have conducted this survey with more participants or with more learning activities or focused on more specific type of mistakes, we could have gotten to some more substantial data, which we hope to do in the future. Thank you.